Another classification called beta-lactamase inhibitor. This is different from the beta-lactamase resistant property of our drug. Magkaiba yung beta-lactamase resistant property and beta-lactamase inhibitors. But sometimes they are combined together. So factors that may contribute to the failure of such combination of our drug is the presence of different enzymes, no, na i-produce ng ating mga bacteria. So first is the failure of most lipophilic penicillinase resistant penicillins to penetrate the cell envelope. So even though we have methicillin, oxacillin, cloxacillin that can be resistant to the penicillins because of their bulky structure, it will still fail. It will still fail because of the lipophilic structure of our gram-negative bacteria. They cannot penetrate it well. So even though hindi sila namamatay, but yung drug hindi namamatay, but they cannot penetrate gram-negative. Another thing is the reversible binding of penicillinase-resistant penicillin to lactamase, requiring high concentration to prevent substrate binding and hydrolysis. And induction of lactamases, that pararamihin nila yung production of the enzyme to overcome your cloxacillin and dicloxacillin. So that is why we have drug that is called beta-lactamase inhibitors, so that it can assist our penicillins. It will be the one to combat the enzyme so that our penicillin can reach wherever it needs to be working on. So these products are the clavulanate potassium. We have it in our oral drugs and IV drugs, and then we have sulbactam and tazobactam. The next group under penicillin is the cephalosporin. So the structure-activity relationship among the cephalosporins appear to be parallel with penicillins because they carry the same pharmacophore called beta-lactam ring. So, yan. But they have different side chains. Okay, they have different side chains and different R groups. Okay, so in penicillin, we only have one area for substitution. Just one area for substitution in penicillin. But in cephalosporin, we have 2 and 3 areas for binding or for substitution. So for further elaboration, this is the R1, the 6th position of penicillin, where you will do substitution to enhance spectrum of activity, to enhance the coverage of our drug, and to enhance its property like beta-lactamase resistance. But in cephalosporins, in the 7th position, the R1, and we have the R2 here, this one here. We can have R2 here and the R3. Okay, so we can have 2 or 3 places for substitution. So let's have first the oral cephalosporin. So the oral cephalosporin, its activity is conferred by the presence of phenylglycyl substituent, and it has an increased acid stability of the beta-lactam ring. So the beta-lactam ring, it is prone to acid degradation. Okay, so we need to enhance it by adding, for example, phenylglycyl. Phenylglycyl will help overcome the acid and allows the drug such as cephalosporin to be given orally. So it allows high acid stability of the cephalosporin. Okay? Oral activity can also be conferred by esterification of the 3-carboxylic acid group to form acid-stable lipophilic esters that undergo hydrolysis in the plasma. So the removal of our 3-carboxylic acid will allow acid stability because we all know that carboxylic acid is prone to degradation by our gastric juice. So an example here, cefuroxime, acetyl, cefpodoxime, proxetyl. These are two beta-lactamase resistant alkoximinocephalosporin that are orally active ester prodrug of our cefuroxime and cefpodoxime. So we can make prodrugs so that this will be able to reach our small intestine. Okay? So, kung hindi natin gusto ma-degrade sa gastric area or sa ating stomach, we can add our acid, we can form acid stable components na pwedeng siya yung i-target ng ating acid. Siya yung upgrade natin to make our drug become a prodrug, and it will be activated later on in the small intestine. So this one is the general structure of our oral cephalosporin. So oral cephalosporin has 3 places for substitution. And the X here is also a substitution place for electron withdrawing group. When I say 3 places for substitution, it's referring to the substitution of R group or alkyl groups. So we have here cephalexin, yan, cefdin, cefaclor, yan, cefuroxime. So ito yung mga nakalagay ngayon. Apart from the main structure, these are added into the areas for substitution. The R1, ito yung ilalagay for cefuroxime. In the R2 part, ito yung ilalagay. And for the R3 part, ito yung ilalagay. And then for the X part, you'll add sulfur as the electron withdrawing group. And then we have cefexime here. So let's move forward to the parenteral cephalosporins. We have to take note the principle of the hydrolysis of ester inside the body. So hepatic and renal esterases in vivo will inactivate our parenteral cephalosporin because of the 3-acetoxymethyl substituent. So we need to make our parenteral cephalosporin lacking with this hydrolyzable group. Yung target ng ating katawan or ng mga esterases, then why not take it out or remove it so that wala na siyang target and our drug will become stable and it can be administered that way. Okay, so that is why parenteral cephalosporin lacks hydrolyzable group so that it will pass through or it will be saved from the hydrolysis of esterases. Okay, so tinanggal yung ating hydrolyzable group such as the 3-acetoxymethyl substituent para hindi na siya matarget ng ating hepatic and renal esterases. So that would be available as a parenteral cephalosporin. So this is how a parenteral cephalosporin looks like. So compared with the oral, the parenteral has only 2 places for substitution. Okay, it has only 2 places for substitution, the R1 and the R2. And as you can see, the S or the electron withdrawing group is constant. Okay, nandyan, constant siya. So, ito yung ating parenteral. Now, with regards to the spectrum of activity, our cephalosporin has broad spectrum of activity, and it is more resistant to inactivation of beta-lactamases. Okay, it can be given to gram-positive and gram-negative, and it has better activity against beta-lactamases. And it is more permeable in the bacterial cell wall. That is why it has an action on gram-negative. And its intrinsic activity against bacterial enzyme involved in the same way of cell wall synthesis and cross-linking of our penicillins. Okay, so for beta-lactamase resistance, their susceptibility varies, but it's significantly less sensitive compared to the penicillin. So it is attributed to the bicyclic Cephim ring. Okay, the bicyclic Cephim ring, this one here, this one, it's the bicyclic Cephim ring. It makes our cephalosporin less sensitive to beta-lactamases. Okay? And then we have cephalotin and cefoxitin. They are the most resistant beta-lactamase resistant drug or cephalosporin. And we have cephaloridine and cefazolin. They are the least resistant to beta-lactamase. So we can still upgrade our cephalosporin by adding polar substituent in the amino-acyl moiety of cephalosporins in order to confer stability to some beta-lactamases. So polar substituents is added to confer stability against beta-lactamases. Where should you add it? In the amino-acyl moiety. So, saan si amino-acyl moiety? Okay? Here. Diyan. Pwede natin ilagay. That is amino, and this is acyl. So, this we can add polar substituent to confer beta-lactamase resistance. Two structural features confer broadly based resistance to beta-lactamase. So, an alkoxy-amino function in the amino acyl and a methoxyl substituent at the 7th position of the Cephim nucleus called cephamycin. So, these are the specifics of different examples of cephalosporins that explains their ability to be resistant against beta-lactamase.